Hi, love Scylla? Prepare to love it even more. I'm Dor, the CEO of Scylla and a co-founder. Welcome, sea monsters of the world. Kudos for making it through 2020, and we're here in the beginning of 2021. I hope it'll be a better year for all of us. This is the 5th Scylla Summit and the first virtual event of ours. We're doing a virtual event due to COVID. We really like to see everyone in person, but on the other hand, it allows us to touch many more people. We have a record high of number of attendees, and we're excited to begin. We have this content for amazing brands that will share their Scylla stories together with our developers who will share development and the roadmap. Scylla already runs under the hood by many leading services, and I bet you have at least one, or if not 3 or 5 applications on your mobile phone that uses Scylla under the hood. 2020 was the year of progress and achievements for us. It started by us winning the Technology of the Year award by InfoWorld, completely unbiased. We also completed parity with Cassandra after 5 or 6 years of work. We even passed the functionality of Cassandra with things like chain data capture and sharded drivers. And we added a complete whole new database API called the Alternator. It's a code name for us for DynamoDB compatibility. And we managed even to partner with AWS themselves, offering Alternator in their Outpost deployments, which is a hardware device racks that folks can run on-prem and get AWS API on-prem. And there we provide you the DynamoDB compatibility. So Scylla provides you NoSQL with no limits. We're unlocking limits all the time. We unlocked at the beginning the limit of the number of cores, so you can run 400 virtual CPUs in a single machine, or 60 terabytes in a single machine as well, host them, or just recently we've made it really, we've made a big improvement in terms of having very large partitions, and there's a performance session about exactly how we're making it. We continue to unlock limitations. At the end of 2020, we released a nugget in the form of a Jepsen test conducted by Kyle, and Kyle will share his experience with Scylla, all of the tests, the extensive tests that he has made, the bugs that he found, and also the fixes and his recommendations. But now it's safe to run LWT transactions with Scylla. Now I'm proud to switch to another unlocked achievement, and our Scylla operator for Kubernetes is finally GA. We sat on the fence with Kubernetes for quite some time because Kubernetes was created for stateless applications, and with stateful applications it's much more difficult. For example, if you choose to decommission a node, Scylla needs to know that, and it's different than a regular node removal because we like to move and find another replica for the dataset. Now it's GA and it provides you more functionality. It doesn't provide the performance that the bare metal installation will give you, but it has additional functionality and will close the performance gap over the course of this year. So let's see, for example, how functional is the Kubernetes deployment. So if you like to roll a configuration change without Kubernetes, you need to make sure that the same YAML reaches all of the nodes, that you restart all of the nodes, but not at once, because then you have lack of availability. So you need to do that once, one at a time. And if something goes bad, you need to revert it. With Kubernetes, everything is handled for you. So it's safe because you need to keep the configuration change only in one place. And Kubernetes is the one that is doing the rolling configuration change and the restart. And it's safe and quick. So you can now switch to Kubernetes like several other companies who switch large-scale deployment to Scylla with Kubernetes, and you can do a bunch of other things like version upgrade and scaling out, scaling down. It provides lots of value for those of you who manage your database yourself. For those who rather have a managed solution, we have also used an unlock limitation. So in the past 2 years, we've been offering Scylla Cloud on AWS alone. Today, we announced that Scylla Cloud reaches GCP. Currently, it's in the beta stage, but we'll shortly provide the GA version. And you can do a free trial on GCP or AWS quite easily. We have a session about Scylla Cloud. We demonstrate that with only 3 nodes, you can do more than 1 million operations per second. So it's simple, it's quick, and it's cost effective. No other database will allow you to reach 1 billion operation that quick and for this amount of money. You can also run DynamoDB API on GCP now and be compatible with it and have cross-cloud deployments. So you may ask yourself, what we're going to do next? We have already 2 databases API, plenty of deployment options. Of course, we'll do Azure too. I almost forgot. But what will we do next? You may know that we have a small Redis API. Should we expand it? Should we develop the Parquet project, student project that we launch? Should we eliminate and carve out another round trip from Paxos? So we wanted to share the roadmap with you. Now, we'd like to focus on elasticity and maintainability of Scylla over the course of the next year. We believe that even today we're doing a better job and the ease of use is better than other options like Cassandra, MongoDB, and Redis. But Scylla also have rough edges that we like to polish. Remove node can be tricky. There's the concept of seed nodes where seeds are a special case. All of the Scylla nodes are homogeneous, but a seed needs to be configured. And if you fail to configure it, you may reach unavailability. So we're removing this concept. And sometimes it's not that easy to add nodes. Some compaction strategy could have not be able to undergo major compaction, and there are other limitations that we like to unlock. Compaction, it's a solved problem with Scylla, not with other databases. We like to make repair a fully solved problem, and I think that we're moving into this direction. So altogether, the API is good. We like to make it as good as possible in terms of simplicity, elasticity, data consistency, and the consistency of performance. For us, it's not enough to say cloud native by having a Kubernetes operator or deployment on all of these things and Grafana dashboard. We like to make it super smooth so you wouldn't err and it'll be easy to use always. In order to do that, we're launching Project Circe. Just this morning, we published on our website a special page for this project. If we go back to the Greek mythology, we'll discover that Scylla wasn't a monster to begin with. It was a beautiful nymph that got cursed by Circe, the witch, and formed it into a monster with 12 tentacles. So we like to form Scylla from a database into a monstrous database, but in a positive way. How we'll do that? We like Scylla to gain improvements in all of these fronts. So Project Circe is a year project with month-to-month progress, which we'll share on the website and on our blog. Conceptually, you can see this type of changes that we'll do. We're not committing to specific dates, but you'll have plenty of improvements across the board. Let me cover some of them with you, and the rest will be covered through the other sessions in greater detail. One of the main things about Project Circe is the Raft transformation. Raft is a consensus protocol and will allow us to leap forward with many things. So today, without Raft, you can have either eventual consistent operations with Scylla or transactions, lightweight transactions, but there you pay a penalty of 3 round trips. Quite expensive. With Raft, you'll be able to enjoy from strong consistency without any performance penalty. So this is outstanding. It's outstanding in terms of data consistency and also in terms of end user developer simplicity, because you always can read your own writes. It's consistent from the very beginning. It's also helped us as database developer to provide smoother operations, maintenance, and elasticity, because everything is consistent immediately. Raft today is already implemented in C Star. You can see that in the code base, but we're changing the algorithm to support Raft. Let me give you an example. So when you grow a cluster, let's say if you're growing a cluster from 3 to 4 nodes, this is easy peasy because the nodes are homogeneous, and once you add a node, then data automatically get distributed and no problem at all. But what happens if you like to grow the cluster to double the cluster from 3 to 6 nodes or from 50 to 100? Then it's a longer process, and Scylla, because we derived the algorithm from Cassandra, doesn't have transactional topology changes. So we require you to grow 1 node at a time. So you'll add a 5th node and a 6th node. Now, every time that you add a node, the existing node contributes a data set to the new joining nodes. But if you're growing and doubling the cluster, then you'll have a case where the second node contributes data set to the node number 4. That node, respectively, later on contributes subset to node number 5, and it contributes subset to node number 6. So it wasn't efficient. There was a big waste in data movement, and also everything was serialized, super slow. So that's definitely not good. With Raft, we're making topology changes transactional. So it means that these 3 original nodes will be able to come up with a transaction on the metadata of range ownership and plan ahead of time which data lands into which nodes and have a plan. This takes a millisecond, and later on send the data in parallel to all of the nodes. So there's no need to shift data back and forth, and everything is in parallel. It's a huge boost. This is only one of the benefits of Raft. Another benefit is a schema agreement, to have a transactional schema agreements. And there are more advanced topics, and there is a Raft presentation that I encourage you to watch. Beyond Raft, there are improvements in maintainability. Scylla is designed to be easy to operate with schedulers that allows you to have low latency while you send a lot of data between the nodes. But there are more concepts. We talked about seedless nodes before. There are cases where the dataset does not meet the assumptions of the running compaction algorithm. Usually it happens on migration, or when you add nodes, you suddenly get a bulk of data that is not leveled to match the compaction algorithm. We call it off-strategy compaction, and we're fixing it in a more efficient way. So once you migrate, we'll run one time off-strategy compaction, and everything will get back the way it needs to be. The same happens with major compaction for time window. It's another private case of off-strategy compaction, and it's already implemented upstream. Also, major compaction is simple with the enterprise feature of incremental compaction. It's really not expensive to have a major compaction. That's quite convenient. And lastly, there's a fantastic feature called repair-based node operations. Scylla allows you to store tons of data per node, up to 60 terabytes of data per single node and growing. Now let's say you're storing this amount of data per node, and let's say that you're about to stream this data to another node. Since it's a lengthy operation that can take hours, it doesn't take days, but it can take hours. If you need to restart a node in the middle, then just like that, you would need to restart the whole thing again, and you lose several hours of operations, and that's not good. So we're improving it with repair-based operations. Repairs compares the source and destination data and just sends updates. So it can start from the point that it left before. So it's a big improvement in maintainability. It also relieves you from running repair at the end, because today after streaming you need to run repair. And since we use repair under the hood, no need to run repair again. This is already committed in the source code, but we haven't moved it into the default because we're stabilizing and fixing the last bugs with it. For elasticity, there are more things than what I demonstrated. For example, we want to make sure that there are no stalls during cluster resize. It means that we're going after micro stalls, like 5 millisecond stall during a repair. For us, it's a bad thing, and we try to trace it and release the CPU so an important transaction can be completed at the middle, and we'll go back to that data movement operation later on. Another thing with Raft, because data by definition is transactional and it's consistent across all of the replicas, for the Raft consistency there's no need to run repair at all. So things become simpler, more performing, and the result is that you can easily increase and decrease your cluster without doing too many operations on it. Beyond this, there's more to it. There's observability and Grafana session about monitoring, and we're bringing CQL into Grafana, so you'll be able to query virtual tables in it. That obviously change data capture is in GA now. Overload protection and other things that I cannot cover in my session. Go ahead and attend the other sessions, enjoy them, and make sure you attend the training too. The training is live on the Thursday, and there is a cloud track and a developer track. Thanks a lot, and hope to see you in person in 2022. Bye-bye.